Hello everyone. In the previous two parts of my 555 timer series here, we've looked at the monostable operation of the 555 timer. We've also looked at the astable operation of the 555 timer. And today we're going to look at the third state, which is the bistable operation of the 555 timer. The circuit for bistable mode is fairly simple. It's these two 10K pull-up resistors which are connected to the reset and trigger pins. They are also connected to these two push-button switches. And then there is the standard control pin capacitor here. So in bistable mode there is no RC timer, so there is no resistors and capacitors on the trigger or threshold pins. As well, pin 7, the discharge pin, isn't connected at all in this state. So in bistable mode, the 555 timer is acting as a flip-flop circuit. And in a flip-flop circuit there are two stable states. So the two states of the bistable operation are controlled with the two push buttons. When we press the trigger push button, it allows the current to flow through from VCC directly to ground, which pulls the trigger pin low, which sets the output to high on the 555 timer. Now the 555 timer will wait until the threshold pin is at 2/3 of the VCC voltage before it turns it off again. Now because we have the threshold pin here tied directly to ground, the threshold pin will never be able to reach 2/3 of the VCC. Once the trigger pin is pressed, the output will stay on. To turn off the trigger pin, we press the reset button. And when we press that reset button here, it's allowing the current to flow from VCC to ground again instead of coming over here to the reset pin. And that will reset the state of the entire 555 chip and it will turn off the output. So just like the other 555 timer circuits here, I'm going to have an LED on the output. There's going to be an LED sinking current and there's going to be an LED sourcing current. This way we'll be able to easily tell what state it's in. Okay, so let's put together this circuit. So if everything's hooked up correctly here, pressing this button should turn on the bottom LED. And when the chip starts up or we press this button, it should turn off this LED and turn on this LED. So when the 555 timer is in its default state, the output pin sinks current, and that means that it would allow the power to flow from the positive through the LED back into the 555 timer and out through the ground. When the 555 timer is triggered, then what happens is the output pin does the opposite. It sources current, which means instead of allowing current to flow in, it's taking current from the VCC and sending it out. And because of that, it will flow out of the output through this LED and down to ground, which should illuminate this LED. Basically here what we have is we have pin 1 hooked up directly to ground, pin 8 hooked directly to VCC, which is standard. We have pin 2 coming over to the trigger switch. We have pin 4 coming over to the reset switch. We have pin 3 of course going out to the LEDs for demonstrating. Over here I have a decoupling capacitor that I keep forgetting to put onto these circuits. We have pin 5, which is the control pin connected to ground through a 0.01 microfarad capacitor. We have pin 6, which is the threshold pin connected directly to ground. So these resistors are 10K resistors. These resistors on the LEDs are just 1K resistors because I don't want the LEDs to be too super ridiculously bright. And let's try the circuit now. So you can see that in the default state the top LED is on, and this is because of course the output of the 555 timer is sinking current. It's allowing the current to flow from VCC through the LED and into the 555 timer where it comes out the ground pin. Now when we press this trigger pin, theoretically that should switch and the output should go high and should start sourcing current, which means it should send current from the VCC input of the 555 timer into the output pin, and then through this lower LED and down to ground. So now we'll press the button here, and you can see it works exactly as we thought it would. The bottom LED illuminated and the top LED deluminated. Because there's no timing circuit on the 555 timer in bistable operation, it means that the 555 timer's output will stay at whatever state you last set it to indefinitely. So because I have hit the trigger here, it's outputting the current, it's going to stay like that until the power source turns off or runs out of power or drops below the minimum voltage of the 555 timer. Same thing, now that I've reset it and it's doing the opposite, it will stay in that state indefinitely as well. In the next 555 timer episode, we'll take a look at some of the basic circuits you can create with it and some of the neat little projects. So I hope you found this episode of Tinkering with Terrius interesting or helpful in some way. If you enjoyed this episode of Tinkering with Terrius, then make sure you like and share this video. And if you haven't already, then you can subscribe to the channel. If you have any questions or comments about this video, or you have any ideas for future videos, then please leave them in the section below. Otherwise, you can email them to me or tweet them to me. Thank you for watching. I hope you have a wonderful day.